Yo, what's up future engineers? Welcome back to my YouTube channel. And don't forget to subscribe, like, and hit the notification bell. Hello everyone, welcome to my classroom. Our topic for today is Introduction to Conic Sections and Circles. For our lesson outline, introduction of the four conic sections along with the degenerate conics. Second, definition of a circle. Third, derivation of the standard equation of a circle. Fourth, we have graphing circles. And last, solving situational problems involving circles. An overview of conic sections. A conic section, or simply conic, is a curve obtained as the intersection of the surface of a cone with the plane. The three types of conic sections are the hyperbola, parabola, and ellipse. And our topic for today, circle. It is a type of ellipse and sometimes considered to be the fourth type of conic section. An overview of conic sections. You will see a cone and a plane. As they intersect to each other, it will form a circle, ellipse, parabola, and hyperbola. The definition and equation of a circle. A circle may also be considered a special kind of ellipse, for the special case when the tilted plane is horizontal. For our purposes, we will distinguish between these two conics. As you see the figure A, these have point A, point B, and point C, and also point P. The coordinates of point A is negative 2, 1, B, 6, 5, C, 3, 1. As we get the distance between point A to C, we have a distance of 5. Point B to C, we will use the distance formula because it is a slant line. So the distance formula is given by square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So the distance between point B to point C, x sub 2 is 6, x sub 1 is 3, so we have 6 minus 3 quantity squared plus y sub 2 minus y sub 1, which is 5, is the y sub 2, and y sub 1 is 1. We have 5 minus 1 quantity squared, so the distance between point B to C is 5. You will notice that point A and B, the distance is the same. So there are other points P such that line segment PC, the collection of all such points which are 5 units away from C, forms a circle. For the definition and equation of a circle, we have of our figure A and B. Let C be a given point. The set of all points P having the same distance from C is called a circle. So as you will notice, the point C is called the center of the circle, and the most common distance is called the radius. The term radius is both used to refer to a segment from the center C to a point P on the circle and the length of this segment. Definition and equation of a circle. See figure B where a circle. For the definition and equation of a circle, let us see the figure B where a circle is drawn. It has a center of C, H, K, and a radius of R greater than 0. A point P, X, Y is on the circle if and only if line segment P to C is equivalent to R. For any such point, then its coordinates should satisfy the following. Line segment P to C is equivalent to R. If you will see, it is a slant line, so we will use the distance formula. Our x sub 2 is x, Our x sub 1 is h, our y sub 2 is y, and our y sub 1 is k. Therefore, we have x minus h, open and close parentheses, raised to 2, y minus k, open and close parentheses, raised to 2 is equivalent to r. For us to remove the square root, we have to multiply both sides of raised to 2. Therefore, our standard equation is x minus h, open and close parentheses, y minus k, open and close parentheses, raised to 2 is equivalent to r squared. If the center is the origin, then h is equivalent to 0 and k is equivalent to 0. The standard equation is then x squared plus y squared is equivalent to r squared. For our number 1, with the center at the origin and radius of 4. So the standard equation of circle with the given formula of x minus h quantity squared plus y minus k quantity squared is equivalent to r squared. You will notice the center at the origin. It means our h is equivalent to 0 and k is equivalent to 0 with the given radius of 4. So the answer for this is x minus 0 quantity squared plus y minus 0 quantity squared is equivalent to 4 squared. So the standard equation is given by x squared plus y squared is equivalent to 16. For our question number 2, with the center of negative 4, 3 and the radius of square root of 7. Our standard equation of circle is x minus h, open and close parentheses, raised to 2. Y minus k, open and close parentheses, raised to 2 is equivalent to r squared. So, our center is given by h is equivalent to negative 4 and k is equivalent to 3 with the radius of square root of 7. So, i-insert lang natin sila dun sa given standard equation. And the answer is x minus negative 4, open and close parentheses, plus y minus 3, open and close parentheses, is equivalent to square root of 7, open and close parentheses. To result of x plus 4, open and close parentheses, raised to 2, plus y minus 3, open and close parentheses, raised to 2 is equivalent to 7. For problem number 3, we have the given of circle in figure A. The figure A is our previous example with point A, negative 2, 1, B, 6, 5, and C, 3, 1, with the same distance of 5 or radius of 5. So, our center is given by h, 3 and k is equivalent to 1. Our radius is equal to 5. And we have to substitute it to the standard equation of the circle, which is x minus 3, open and close parentheses, raised to 2, y minus 1, open and close parentheses, raised to 2 is equivalent to 5 squared. And our answer is x minus 3, open and close parentheses, raised to 2, y minus 1, open and close parentheses, raised to 2 is equivalent to 25. For number 4, for our solution number 4, a circle A in a figure C. So yung circle A dito, let's just focus to the red circle. First, you have to notice what is our center. So our center is given by negative 2, negative 1. And our radius, you can count it vertically or horizontally. Our radius is given by r is equivalent to 4. And our answer is x minus negative 2, open and close parentheses, raised to 2, plus y minus negative 1, open and close parentheses, raised to 2 is equivalent to 4 squared. Therefore, the standard equation of this problem is x plus 2, open and close parentheses, raised to 2, y plus 1, open and close parentheses, raised to 2 is equivalent to 16. For our problem number 5, circle B in figure C. So, ang focus naman po natin dito ay yung blue na circle. Ngayon, if you will notice, our center is given by 3, 2. It will represent H is 3 and K is 2. And you can count for our radius. Our radius is given by R is equivalent to 3. And our answer is given by x minus 3, open and close parenthesis, raised to 2, plus y minus 2, open and close parenthesis, is equivalent to 3 squared. So, therefore, our standard equation is given by x minus 3, open and close parenthesis, raised to 2, y minus 2, open and close parenthesis, raised to 2, is equivalent to 9. For our problem number 6, with the center of 5, negative 6, and tangent to the y-axis. Here is our standard equation. As you will see, our center is given by 5, negative 6, which represent h is equivalent to 5 and k is equivalent to negative 6. Let us define what is a tangent. A tangent is a line and a curve that intersect at one point. The center is 5 units away from the y-axis, so the radius is 5. Therefore, our answer is x minus 5, open and close parenthesis, plus y plus 6, open and close parenthesis, raised to 2, is equivalent to 5 squared. That result, the standard equation is x minus 5 plus y minus 6, open and close parenthesis, raised to 2, is equivalent to 25. For our problem number 7, with the center of 5, negative 6, tangent to the x-axis, given the standard equation of a circle, with our h, k of 5 and k is negative 6. Since it is tangent to the x-axis, the center is 6 units away from the x-axis, so the radius is 6. Therefore, the answer is x minus 5, open and close parenthesis, raised to 2, plus y plus 6, open and close parenthesis, raised to 2, is equivalent to 6 squared. Therefore, the standard equation is x minus 5, open and close parenthesis, raised to 2, y plus 6, open and close parenthesis, raised to 2, is equivalent to 36. For the problem number 8, the center C is the midpoint of A, negative 1, 4, B, 4, 2. In this type of problem, first, you have to graph it, the negative 1, 4, and the 4, 2. Then we need to get the midpoint of the line segment. X sub m is equivalent to x sub 1 plus x sub 2 divided by 2. Y sub m is equivalent to y sub 1 plus y sub 2 divided by 2. So we have negative 1 plus 4 divided by 2 and 4 plus 2 divided by 2. Therefore, our x sub m is 3 over 2 and our y sub m is equivalent to 3. Since the center is the midpoint, therefore we have h, k of 3 over 2 and 3. Also, we need to get the radius and we need the distance formula from the midpoint to the end of the diameter A. So the distance formula is given by x sub m minus x sub 1, open and close parenthesis, raised to 2, plus y sub m minus y sub 1, open and close parenthesis, raised to 2. So the radius is given by square root of 3 over 2 minus negative 1, open and close parenthesis, raised to 2, plus 3 minus 4, open and close parenthesis, raised to 2. Therefore, to get the radius, it is equivalent to the square root of 29 over 4. And then we have to substitute it to the standard equation of a circle. Therefore, our equation is given by x minus 3 over 2, open and close parenthesis, raised to 2, plus y minus 3, open and close parenthesis, raised to 2, is equivalent to 29 over 4.